Okay, so before we talk about this algorithm we need to use for mining the frequent patterns or some item sets, we also need to introduce some patterns we discover about the mining process, right, in this page. The first property we have is called the downward closure property of the frequent patterns. What does this mean? It means any subset of a frequent item set must also be frequent. For example, if we find a pattern already, this X, right, which is frequent, then all its subset will also be frequent as well. We'll also show you with an example in this page. Let's assume if this beer, diaper, and nuts, this pattern is frequent, then this beer, diaper will also be frequent, right? Because if we can find some transaction contain this one, they will also contain this one, right? In other words, the number of the transaction contain this beer and diapers will actually be larger than this number of transaction contain this one, right? This will be called the downward closure property. And every transaction having this first one will also contain the second one as well, right? It's subset. Besides the downward closure property, another property we have here is called the Apriori pruning principles. It means if there is any item set which is infrequent already, we find some infrequent patterns, then all its subset will be infrequent as well, and they will not be generated. Because we know this will be true, right? Because if we find some pattern which is infrequent already, by putting more items into this pattern, it will not be frequent neither, right? So based on this rule, we can shrink the space for prunings in the learning process or in the mining process. So we can provide some high level for the approaches we can use actually, for generating or for mining these frequent patterns. Initially, we can scan the database system once to get a frequent one item set, right? So by scanning the database system, we can know what item we can have in the database system. And we're going to record the number of appearances for each of the items, right? And then we can combine the items together. We can get the frequent ones, of course, by pruning the infrequent ones. And then we can combine the items together to generate two candidate item set instead, right? So we can set this K to be now 1. Then we can generate two candidate item set from this next one frequent item sets. And we will generate further forward, right, by increasing these K numbers, and we are running this algorithm iteratively. And we can test the candidates against the database system, and also terminate when no frequent or no candidate set can be generated. This is a high-level idea for mining the frequent item sets. We will show you with the example. Let's assume we have a database system. This contains 4 transactions of the database system. For the transaction 10, we have ACD, 20 we have BCE, 30 we have ABCE, and last one we have BE. According to the high-level idea of the algorithm we showed in the previous page, so we can scan the database system first, right, to generate this one frequent one item set. So based on the database system, by scanning it, right, we can get all the items in the database system and also record their frequency or their support. According to the table we show here, we have 5 different items, A, B, C, D, E, right? We have the items in this table via scanning, and we also have the support numbers for each of the items, actually, according to the table, right? We have 2 transactions contains A, 3 transactions contains B, and 3 transactions contains C, 1 transaction contains D, and 3 transactions contains E, right? If we define the mean support threshold to be 2, according to this table, we can find one D will be infrequent, and all the remaining will be frequent, right? So by pruning this D, we can generate this first one frequent item set to be this table, A, B, C, E, right? All this support will be larger than the mean support. And according to the previous algorithm, based on the frequent one item set, we can generate the frequent 2 item set candidate sets, right, by combining them together. So we know this will be the frequent one item set. By combining the items, we can generate this frequent 2 item candidate set in this page, right? So by combining A, B, C, E, we can have different combinations. We can have AB, AC, AE, BC, BE, and CE, right? This is called candidate set. And based on this candidate set, we can scan the database, these tables again, get the support for each of them. Like for example, we can get the AB, its support will be 1 because we're going to have 1 transaction contains AB, right? This one. For AC, support will be 2, right? We have 2 transactions AC contains AC, and also this one contains AC, right? Similar for the remaining ones. And also according to the main support threshold, we can also prune these infrequent item sets from this table, this candidate table as well. In other words, by removing this AB and AE, we can get the frequent item set to be AC, BC, BE, and CE. Both of them will contain 2 items, right? And now come to the table, we can further go up forward by putting more items into them to get 3 frequent patterns, right? So by combining AC, BC, BE, and CE, we can define a candidate set containing all the 3 items, which will be the BCE, right? ACE, right? And those will have different combinations. According to the table we show in this page, we know that this BCE will be frequent, right? Therefore, for the 3 frequent item sets, they will contain one single pattern, which will be the BCE, which is frequent, larger than the threshold 2 we defined before. All the remaining combinations will be infrequent. Okay, so in this steps, we can define and we can extract the frequent patterns from database tables, step by step, iteratively. We can get 1 frequent item sets first, and then we can get 2 frequent item sets and 3 frequent item sets. Okay, so this is an example. And this example can provide us with some high-level ideas for defining the algorithm we will use, which is called the Apriori algorithm. We will discuss this algorithm in the next page.